Hello everyone, my name is Tas and welcome to new TouchDesigner tutorial. On the screen you can see different results made by applying the sine wave to a pop lines. And this is our topic for today. I will build basic examples from scratch using the math combined pop, and I think it's a good way to show step by step before moving to GLSL. And let's begin with the simple case, horizontal lines. First, I will create one regular line with line pop. I want it to be exactly 1 unit long along the x-axis. This will be useful later because the geometry will match the texture range. Now I will make several copies of this line and move them upwards in y-axis. Let's start with, 10 lines. I want the complete result to feel 1 by 1 square. So there are one fewer gaps between the lines. So the distance between the lines should be 1 divided by number of lines minus 1. So let's make this expression. And now the geometry fills 1 by 1 area. Now let's turn these straight lines into sine waves. The basic idea is simple. We take the x position and transform it with the sine and add the result to the y position. So x position stays the same and y position changes. It will take several operations. First I take the px and multiply it by a value, for example 1, and I will call this frequency. Then I apply sine function to the frequency and I will call it a wave, and finally I will add this wave to the p dot y. At first, the wave doesn't look too wavy. This is because the sine operation in math combined expect degrees. One full sine cycle is 360 degrees, so I multiply the value by 360. I will also increase the number of points in the line, so the wave is smooth. But pay attention, if you build the same operation in GLSL pop, the sine and cosine will use radians instead of degrees, so we'll need to multiply by 2 multiplied by p instead of 360. So now we have one full wave across the line. If I multiply the phase by 720 degrees, we get 2 full waves instead. So it's useful to expose this value as a parameter. I create a uniform called u-frequency, and with u-frequency equals to 1 we get 1 wave, and with u-frequency equals to 2 we get 2, and so on. So this is the frequency. It controls how many times the sine wave repeats along the line. Now let's add the amplitude, and the amplitude controls how far the line moves away from its original position, and in our case moves by y-axis. We could simply multiply the wave by a number, like this, but I want the amplitude to be relative to the distance between the lines. So if I change the number of the lines here, the spacing changes too. And maybe it depends on your project. Maybe you like it, maybe not. But for now, I want the visual relationship between the waves and the line spacing to stay consistent. So I will use the y translation value from the copy pop as a reference. And now the amplitude of 1 means the wave occupies one full line gap in each direction. And for this setup I will multiply it by 0.5, so each wave have half of the space between the two lines. Okay, and now I create u amplitude, and this u amplitude parameter is relative to the line spacing. We can also add the phase offset. Phase offset doesn't change the shape of the wave, it just shifts the waves along the line. And I need to multiply this offset by 360 because it's also going into sine function. So now the changing the offset moves the wave, and it will be useful for making animations that not based from the texture but based by this value. So far, frequency, amplitude, and the offset are controlled by uniforms. Now I want to control them with a texture instead. I will use a ramp top as a simple example, and because we only need one value per pixel, I will use the monochrome texture. I will also use the high precision format, such as 16-bit fixed, because I would like to have the values between 0 and 1 here as well. As a quick check, I can output the sample texture as a color. This makes it easy to see that the texture lines up perfectly with geometry. And working with the line inside 1x1 square is convenient exactly for this reason, for texture mapping. And even if your texture is not a square, only thing you need to do is to add the transform pop, and in scale X, use this expression. Operator, the name of the operator, point aspect. And this scales the geometry to match the aspect ratio of a sample texture. It doesn't matter is it horizontal or vertical format, it will work. But I do not want to use this value as a color. I want to use it as a frequency. And I need only one component, so turn on just red. The texture values are between 0 and 1, and this is not useful for frequency. So let me remap the texture value. I could use the math combine pop for this, but I could also remap the texture straight up here. For example, the black can mean 3 or 5, and the white can mean 25. Okay. Now the texture works as a frequency field, and bright area produces high frequency, and the dark area produces lower frequency. You can also adjust interpolation and extend mode to match the texture better. And there is one important detail here. This setup uses texture value at the current point directly to calculate frequency. In the pattern component, I also included the second method, which accumulates frequency from the beginning of the line to the current point before calculating the phase. When the texture has a very sharp changes in the frequency, neither method can create a perfectly clean result. As you can see, a wave just cannot instantly switch from one wavelength to another without creating some kind of transition, compression, glitch, artifact, whatever. So the two methods just handles this in different ways and produce different visual results. You can try both and use the one that gives you a result that you like most. And the second method uses numerical integration. I will not explain the math in this video, but if you want to research the idea yourself, look up the midpoint rule for numerical integration here. And for Patreon supporters, I'm sharing the sine lines as a ready-to-use component with the custom interface. It includes everything we have built here, implemented in GLSL with like a lot of comments, and also some additional controls. For example, you can set a separate speed multiplier for every line by feeding the chop. So you can use it directly as a component or go inside and adapt the network and shaders to your own projects. Now let's move back to our network. I showed everything using frequency as an example, but you can do exactly the same thing with the other parameters like amplitude, phase, offset, line, width, anything you want. And I think you can handle it yourself because it's absolutely the same kind of operations. So now let's move from the waves to the circles and spirals. A sine wave uses sine to move one coordinate up and down. But if we also add the cosine with the same phase and other parameters, we will get circular motion. And this is the basic for our next example. I can do it with the same line using the math combine, but for this part I prefer to start from pattern pop. I set x to the cosine and y to sine, and when both use the same number of cycles and the same phase, they create a circle. Cosine controls one axis of the circle, and the sine function controls the other axis. And if I increase the number of cycles, I get more circles. I also need much more points, otherwise the circle looks faceted. Now I can use ramp component for z-axis. It will move the circles along the z-axis, so it will look more like a spiral structure. But what if we want the spiral that doesn't have the unique radius but more like a concentric spiral? Okay, pattern pop already gives us texture coordinate with ramps from start to end. That means that we have the value that goes from the 0 to 1 along the line. I will rename this attribute to make it easier to read, because it's not a texture, it's just a ramp. And now I can use this ramp as a radius multiplier. I take p multiplied by this ramp, and now near the start the value is close to 0 and the circle is very small, and linearly along the line the radius grows. And the spiral is just a simple circular motion. With the radius this changes. If you keep this z ramp, the result stays three-dimensional, but I will just remove this z ramp and set it back to 0. Now the number of cycles parameter controls how many turns of the spiral we have. The phase, if we change it simultaneously, rotates the whole spiral clockwise or counterclockwise. And we can also add a constant to the ramp. Before using it, it will give us a certain radius. It gives the spiral, so the spiral starts not from the center but from some distance apart. Okay, and also I can add another multiplier just as a general scale control. And that's it for the spiral. And now let's turn the spiral from the line into a tube, for example. I create a small circle and use the copy pop to place it along the spiral. Well, there is two problems here. First is the copies is not distributed evenly. It happens because the spiral has denser points near the center and wider spacing farther away. So I could use the resample pop to resample this line by distance and create much more even point distribution. This solves our first problem. And the second one is this incorrect orientation. And for solving this, I will use the line matrix pop. This summer in July 26, Derivative adds some new useful pop orientation functions. If you want to learn more about them, I recommend reading this page, or you could also explore the snippets in the pop concepts. Somewhere as rotation snippets over there. And for this setup, we will use the quaternion orientation attribute, this one. And now the line matrix can create a rotation attribute by itself, and in the copy pop I only thing I need is just enable this template rotate and use quad here. Okay, now everything is correctly, and yeah, that's it. There is another related structure you can build here, a cord, like a coiled cable of an old telephone handset, if you remember those, if you have seen those. Remember how we created the spiral in the pattern pop? We used sine and cosine in x and y to create circular motion, and the ramp in z to move this circle forward to create a spiral. Here the idea is the same. But instead of using the global x and y, we will need to use the normal and binormal attributes and apply sine and cosine function to it. So they create a small circle in a normal binormal plane, and it will like move original curve in the forward direction. And this setup is available in the Patreon file as well. I use GLSL for this version because Math Combine is good for like explaining things and showing things step by step, but to create the project I prefer GLSL. But again, it's well commented. Okay, we can also bring the texture control in this spiral the same way. Again, they use the same texture, and let's me call it, I don't know, text data, because I could use this text data for any attributes again, but now I will use it as a scale attribute in copy pop, and this changes the size of the copies along the spiral. Another thing you could do is use skin pop. Skin connects the circles into one continuous tube, and like here, but you need to change the normals, to fix the normals. Also, the skin pop can be useful with the sine lines from the beginning of the tutorial. Like here, it converts the separate lines into a set of layered surfaces. So instead of a transparent line, like here, we get the layered planes or like curtain sheets, I don't know. Okay, and also you could use, for example, the noise pop after the sine function, and the small amount of noise adds some regularity. I don't know, also looks nice. And also because this line is connected, it's create like interesting structures. And for Patreon supporters, I'm sharing these two additional containers. The first one with the spiral and chord, and the second one with this layer setup I just showed. You can go inside the container and inspect the networks, just use the GLSL or do whatever you want. It's all under MIT license, so you could use in commercial project as well. And the sine line setup I provide as a component with the custom parameters. But again, if you don't like to work with the components, you could simply go inside and copy paste to your project whatever you need from here. And that's it for today. And thank you for watching, and see you next time.